Thank you. Um, my name's Dan Dyla, and I'm here to talk to you about OpenTelemetry and distributed tracing in general. Before I get started, I'd like to say a real quick thank you to the organizers of Observability 2020. I know from experience that it is incredibly difficult to organize a conference during the best of times. So they've been dealt a pretty difficult hand here, and they've really done a great job with it. First, I'd like to say a little bit about myself. I'm a software engineer at Dynatrace. I've been here for about 3 years now. I'm also a member of the W3C Distributed Tracing Working Group, which develops open standards to encourage interoperability between tracing vendors. And as a part of that effort, I'm also a co-maintainer of OpenTelemetry JS, which is the JavaScript implementation of OpenTelemetry, which is an observability framework built on open source and on open standards, like what the Distributed Tracing Working Group develops. Today, I'm going to talk to you about distributed tracing as a concept, what it is and why it's useful. I'll give you a little bit of background on the W3C trace context, which is a standard that recently went into official recommendation status. I'll talk to you about OpenTelemetry, which is the observability framework built on that standard. And at the end, I'll show you how you can trace a Node.js application using open source tools. But first, I'd like to start with a simple example about why distributed tracing is useful. So imagine we have here a simple service where a client calls a middleware tier and a middleware tier calls a backend. If this service breaks without distributed tracing, what do you typically do? Well, of course, you go to the logs. And because this is a very simple service with only 2 tiers, this is usually pretty easy. You pull down the logs for the time frame, you find the log line that is the issue, hopefully, and you fix the problem. And everyone's happy. The biggest problem with this is that simple systems tend not to stay simple. As your business grows, your requirements are going to grow. Maybe you add some backend services. Maybe you change your middleware tier so that it's auto-scaling with containers spinning up and shutting down automatically. And maybe you introduce other applications that share infrastructure components. In some cases, you may even have outside applications that call into your infrastructure, and you don't know much about those applications, and they don't know a ton about the inner workings of yours. What do you do when a system like this breaks? Or even worse than that, what do you do when it's only sometimes broken and difficult to reproduce, or just slow? How do you even know that it's broken? Well, logs didn't fail us before, maybe they won't fail us now. So you start pulling down logs. But you quickly realize that you have so many hosts and so many services that you're spending all day looking at logs, and this is your life now. And this is not a life that anyone wants. Looking at logs is boring. No one wants that. So let's look at what this would be like to solve with distributed tracing. Well, we know which service is broken, so we'll just filter all requests by that service. And we know the issue is a slowdown, so we'll just look at the slowest 5% of requests. And we'll find one that we think is interesting. In this case, this request took 7 seconds, which is way longer than it should take. And only 3 milliseconds of that was CPU time. So we know something weird is going on here. So we pull up this trace and we can see, yeah, the second tier here is taking almost all of the time of this request. Now, in many cases, tools can actually show you errors directly within this view, and you're done. But in the cases that they don't, we now know which host the issue is on and the exact time frame, and we can even get a trace ID. So we can pull down the exact time frame of the logs from that exact host on that service, and we can filter them by the trace ID, which makes finding the issues way faster a lot of the time. Advanced tools like Dynatrace and others can sometimes do this for you before you even know there's a problem. It will alert you and say, this is what caused it. And this is really valuable. But the true value comes when you run this in production, when you're analyzing every single request on a production workload. It's like having a debugger in production. So now that we've gone through sort of the motivating example of distributed tracing, I want to talk to you about the core concepts of distributed tracing. And I'm going to start with a span, which is the basic building block of a distributed trace. And it's very easy to understand a span. It's just an operation with a start and an end. So this can be an outgoing web request or an incoming web request, a database transaction, a file read-write, any sort of IO, anything like that. And there are 5 different types of spans. We have client spans and server spans, which make up typical RPC calls like HTTP and things like that. We have message producer and consumers, which are used by messaging systems like Kafka. And we have internal spans, which are sort of a special case span that are used within a single tier of a service typically. And once we understand a span, we have essentially everything we need to understand a distributed trace, because a distributed trace is just a collection of spans. You can see at the bottom here, there's typically represented as like a Gantt chart, like what we saw earlier. And here I've color coded it so that you can see which hosts and services have contributed to which part of the trace. The important thing to note here is that there are more spans than requests in this trace. And that's because each request has the client span, which is the outgoing request, and the server span, which is the incoming request on the other side. So you can see sort of in the first part of the Gantt chart there, you have the little blue line, which is the outgoing request, and the little green line, which is the incoming request on the green service. Typically, they look something like this. This is Zipkin, which is an open source tracing backend. But there are many options. This is what it looks like in Dynatrace. Now I'm going to talk to you a little bit about how these spans get propagated. Typically, when you have an outgoing web request from an instrumented service, it would add a trace ID and a span ID on the transaction as like an HTTP request header, usually. There, in non-HTTP use cases, you have other ways to do this, but we're going to focus on HTTP for now. Here we can see transaction equals ATTY, that's like a trace ID, and then parent ID, that's an ID that represents the span. The issue with this is that every vendor has their own proprietary tracing header, and other systems may not recognize them. So in this simple example, we have service A and service B, which are both instrumented by one system, in this case Dynatrace, and then a middleware service, which may be instrumented by a different service, or it may not be instrumented at all. In any case, it doesn't recognize the Dynatrace headers, and it doesn't know to forward them when it continues the request. And in this case, traces can be broken, and the context is lost. This is the problem that W3C trace context is attempting to solve. W3C trace context is an open standard for propagating trace IDs and span IDs through a system so that traces can be stitched together properly. For now, we're just going to focus on the trace parent header at the top here. The trace state is typically vendor specific. But you can see the first part here is the trace ID, and the second part is the parent ID or the span ID of the parent. They're represented as hexadecimal or hex strings here. But you can see it's a fairly simple process. But the advantage of this, if we go back to the previous example, is that if both systems recognize trace context and know how to deal with them, then the context isn't lost. And even with multi-vendor systems, you can still stitch trace together properly. And this is a huge advantage. Now I want to talk to you a little bit about OpenTelemetry. OpenTelemetry is an open source observability framework built on this W3C standards and on the open source community. It's also a cloud native computing foundation sandbox project. OpenTelemetry started as a merger between OpenCensus and OpenTracing. So if you're familiar with either of those projects, a lot of this is going to sound familiar to you. And it's a huge effort with a lot of different companies contributing. Liz's slide earlier with the logo cloud was much more generous than this one is here, but there are many, many companies contributing. These are just some of the bigger ones. This is a very simple architecture diagram showing how you might use OpenTelemetry and how you use the API. The core idea here is that your application depends on libraries, and libraries can depend on the OpenTelemetry API. But the real advantage of OpenTelemetry is that those libraries should be able to depend on the API without worrying about whether their customers are OpenTelemetry users. This is important because if you have some database driver that wants to export telemetry in an open source format, they can call the OpenTelemetry API methods and export tracing data, and their customers can just decide whether they want to use it or not. In the future, we hope that many open source libraries will depend on the OpenTelemetry APIs, and that it will become a rich ecosystem of spans being exported by libraries that you're already using. But for now, we have external instrumentation libraries. They're called plugins in some circles, and it doesn't really matter what they're called, but they instrument existing libraries to export trace data. This is a little bit more expansive of a view of the previous architecture that I sort of just showed you. At the top, you have the OpenTelemetry API in blue. We're going to focus primarily on the tracing API, but the important thing in here is the SDK, which is all of the green. And the SDK by default does nothing, which means that those libraries that depend on the OpenTelemetry API from before can call it without worrying about if their customers are OpenTelemetry users or not. But if they are, then the SDK will gather all the tracing information and export it to vendors. The OpenTelemetry collector here is used in larger deployments where you have many traces coming in from many different hosts and services, and you don't want to overwhelm your tracing backend. You can export to a series of collectors, which can then batch traces and export them to your vendor. So now I want to walk you through the process of tracing a simple Node.js application. The important things that we're going to go through here are a tracer provider, which is the sort of root entry point of the tracing API, a span processor and a span exporter, which are the export pipeline that get traces out to your tracing backend, and instrumentation libraries, which are what actually gather the telemetry data. So let me close this real quick and move over to my application. So here we have an example of a very simple Node.js application. It doesn't really do anything, it's just an echo application, but you can see we have a root route here, which calls a middle tier route twice. In this case, it's calling itself because it also has the middle tier route, which calls the backend route twice. The backend route just returns hello, and then each tier returns the result of the second call. So it's a little bit contrived, but it's good as an example. So let's quickly install and run this. So install the dependencies. We see we have very few dependencies here. So I'll start the application real quick. And it says it's listening on localhost 8080. So I'll just curl there. And hello from the backend. That's exactly what we wanted to see. So if we go back to our project, we can see nothing was logged, everything is fine, everything's working. So let's go through the process of instrumenting this. The first thing that I need to do is install the dependencies. So we'll install OpenTelemetry Node, which is the Node SDK for OpenTelemetry. And we're going to install OpenTelemetry Tracing, which gives us some tracing libraries. And to keep this simple, I'm going to add all of my tracing code in an external file that I'm just going to call tracing.js. So the things that I mentioned earlier, we need to create a tracer provider. We need to register a export pipeline. And we need to register the SDK with the API. So let's go through that. First, we'll say the node tracer provider comes from OpenTelemetry node. And we'll grab the simple span processor and the console span exporter from OpenTelemetry tracing. So let's create our provider. And we'll create an export pipeline. And the simple span processor takes a console span exporter. The important thing here is that the simple span processor is exactly what it says. It's simple. All it does is forward traces to the exporter. But there are different span processors, like batching span processors, and you could theoretically have span processors that do other things also. So we'll register this with the provider. And we'll set up the SDK to use the API. In OpenTelemetry JS, we have a convenience method for this. Just call it register. But in other languages, it may be different. So now we need to load this telemetry code before our application code runs. Node.js has a convenient mechanism for this, which is just a command line flag that will run a file before the application code runs. So now let's run this again. Oh, cannot find module plugin HTTP. Okay, so this happened because our application code is trying to load a library that the SDK knows is an instrumented library, but we didn't install the instrumentation library for it. So let me quickly install that. So I saw plugin HTTP and plugin HTTPS it was asking for. So now we'll run it again. Okay, so we can see at the bottom, the plugin loader loaded the HTTP and the HTTPS plugins at the startup of our application, which is good. This means that HTTP requests are now automatically instrumented with no change to our code. So if we go back to the other example here and make a request, we should now see on the console all of the spans that have been exported. Now this is great to know that this is working, but there's no real value in logging this to the console. Then we're just back where we started, where you're looking through logs all day. So let's see how we can send this to a tracing backend. In this case, I'm going to use Jaeger. So first we have to install the Jaeger exporter dependency. I think I had that backwards. Exporter Jaeger. There we go. Okay. So I'm going to get rid of my console span exporter. And instead, I'm going to create a Jaeger exporter. A new Jaeger exporter, and the Jaeger exporter requires a service name. So So we'll just call this example. And now I need to start a Jaeger backend. I'm going to use Docker for this, but there are many ways to do it. Okay, so now let's make sure that that's running, and it is. So let's run our application again. And we'll make another request. Hello from the backend, exactly what we expected as before. If we go back here, we see that it's not logging to the console anymore. But if we go to our Jaeger tracing backend, we now see this example service. So we'll just get the last 20 traces and we can see our request here. So if we click on it, now we have a much more visual example of what was going on. So as I said, the root request calls the middle tier twice, and each middle tier calls the backend twice. Again, we have 2 spans per request because you have the client side of the request and the server side of the request. And if we click on any individual span here, we can see a ton of rich data about the request. This is similar to logging, but it's all in a single place where it's easily searchable and machine understandable, which is a huge difference and a very important distinction. So I had some extra slides here in case that did not go well. So that's what I have for you guys today. If you're looking for more information and you want to get involved, please go to OpenTelemetry.io or find us on GitHub at OpenTelemetry. There's also a Twitter account, OpenTelemetry, if you're just interested in what's new and what's going on. Paul was very gracious and created a page for me to have my talk on if you guys are interested in it later at bit.ly Observability 2020 Dyla with the observability abbreviation here. And I'll be answering questions in the speaker-Dyla channel or in the Dynatrace booth channel.